This conference will now be recorded.
Okay, so make sure that if you haven't already set the time for your final exam, make sure you've set that. I've actually, I think I've had it set to open on this coming Friday. If anybody is interested in that, to take it, Friday or Saturday of this week to finish a little earlier. Otherwise, next week is our last week of classes. And so, um, Monday of next week will be a review, just like I've done in the past, where I'll kind of just give you a hint on what areas to study for. I do have a sheet, and I'll post that later on in the announcements of the topics to make sure that you're familiar with for the final exam. So you'll want to take a look at that in the announcements later today. And so then you can ask me any questions that, if there's still something that you're not quite sure of, we can go through that next Monday then. But today I'm going to attempt to get through section 16 and 17. Section 16 is on probability. The first half of this is how to calculate a probability, which most of you probably remember from the past. It's just the conditional probabilities that are a little bit trickier, that we have to pay attention to the wording. And then for the second half of this, we're going to learn how to create our own probability table. So it's really important that you know how to create your own probability table. Hint, hint, because most likely you'll have to do that for the quiz or exam and then answer questions about it, answer the probability questions. So it's really important to know how to do that. So I'm going to be going through just the main points of this, not as many problems today. I just want to make sure that we understand how to do everything today so that I can get through those sections. All right, so let's start with our probability here. All right, we're going to just kind of break right into a problem here. And so here's just a place where we've gathered some data, and notice what the data is about. It says this is minutes that customers waited for service at a fast food restaurant. This is how much they waited in line. And so you can see, it's just randomly, we just have all the numbers there. Okay, so here's the raw data that was collected. Now, what you need to do with this raw data is to create a frequency table. All right, a frequency table is just going to organize this data by counting the types of data that we have present. From there, from the frequency table, we can calculate the proportion of these customers that waited a certain number of minutes. So let's take a look at what a frequency table might look like for this scenario here. Okay, so what are we looking at? We're looking at the minutes that customers waited for service. So if we look at this, it looks like the least amount of time as I'm looking at this table was 1 minute. And it looks like I have no two-digit numbers here. So the biggest number I have is 9 minutes. So I'm going to number from 1 through 9. Okay, now what I'm going to do is I'm going to go through the data and I'm going to find the frequency. In other words, the number of people that waited 1 minute or 2 minutes and so on. So that's what we're looking for here. Now, this can be done a number of ways. It could be done by finding, like, just doing tally marks here, or, you might want to go and kind of go row by row and count and cross off as you're going along, whatever works for you. But we've penciled in the first couple here. Now, the proportion of customers is basically how many people waited 1 minute out of the total number of pieces of data. Well, if we look up here, there's actually 50 pieces of data here. So 50 people were asked how many minutes did they wait in line at the fast food restaurant. So what we're going to do is we're going to take the part out of the whole to find the proportion of customers that waited the certain number of minutes here. So you can see here when we figure out this, only one person waited a minute, so that's 1 out of the 50, part out of the whole, which is 0.02 in the form of a decimal. If I convert it to a percent, that's 2%. 3 people out of 50 waited 2 minutes, which is 6%. And then you can see if we finish filling in the table, here would be the rest of the percentages here. Now remember, since I'm looking at part out of the whole, all these numbers here should add up to 50, and all these percentages here should add up to 100%. Now, sometimes if you're rounding out the decimal, you might wind up with like 99.98 or something like that, which basically if you rounded it out, it would have been 100%. So rounding the proportion overall is going to make it just a little less accurate, but it still will approximately be 100% when you round it at the very end. Okay, so that's how we calculate the proportions here. Okay, and you can see here it says, what is the mode for the number of minutes waited here? Well, remember the mode is the number we see most often. And so in this particular case, that looks like 5 minutes because 12 people waited 5 minutes. The longest somebody waited was 9 minutes. And it's saying here, does this mean that no one ever had to wait longer than that? Well, no, not necessarily. It's just that for this survey, that's all the data I had for this survey was up to 9 minutes. So we can't say that. Now, it gets a little trickier when we start asking some different types of questions. So look at number 3 here. How many people from this data waited at least 6 minutes? Okay, at least 6 minutes. They're not saying 6 minutes total, at least 6 minutes. So that could be 6 minutes, 7 minutes, 8 minutes, or 9 minutes. So if we add all that up, that's 19 out of 50. Okay, so we want to be careful. The problem with probability is we have to be really observant with the wording. That's going to make the difference of if we get the answer correct or not, is paying attention to how are they asking that question there. Okay, so how many people from this data didn't have to wait more than 3 minutes? Okay, so that means we're going to see who waited 3 minutes, 2 minutes, or 1 minute. So that was 10 people. Okay, remember the total proportion should total 100% there. Okay. Oh no, that's just a bonus slide. That's something different. Okay, so what proportion of customers waited 5 minutes? Okay, so we look at 12 people out of the 50, which wound up to be 24%. So remember, first we're getting the decimal equivalent, then we're getting and converting that to the percent. Okay, now, if you were to select a customer at random, so like when we're saying at random, just think, people's names in a hat. What is the probability that they waited 5 minutes? Well, that's 12 out of 50 or 24%. So remember, when they're saying at random, always think random means, I'm just picking randomly. I got names out of a hat here because that's going to come into play a little more. Okay, what's the probability the customer waited 1 or 2 minutes? Okay, so they could either wait 1 minute or 2 minutes. Well, all together, that's 2% and 6%. So that means 1 or 2 minutes. I'm going to add these because it could be one or the other. So I've got an 8% probability that I'm going to pick somebody that's going to wait 1 or 2 minutes. In other words, 4 out of 50. Okay. What's the probability somebody waited less than 10 minutes? Well, that's 100% because everyone in this survey waited 9 minutes or less. Okay, no one waited more than 10 minutes. And here's another one for number 12. What's the probability the customer waited at least 7 minutes? So remember, when they say at least, that could mean 7 minutes, 8 minutes, or 9 minutes. So if we add these up, that's 11 out of the 50, or 22%. Okay, so remember, you really want to be able to know, watch the wording. If you have to create a probability table, this is how you would create one. What does the proportion mean? The proportion is an easy thing. It's like the part out of the whole. So the whole here was 50 people. So the basic definitions here, when we look at it, if you flip a coin, we know that there's a 50% chance of getting heads or tails. Okay. And if it's saying we're rolling a die, what's the probability of rolling a 5? 1 out of 6, because it's a 6-sided die. Okay, so you can see we're probably familiar with these kind of probabilities. Okay, so in general, the definition for finding a probability is the number of ways, oops, let me see here. For probability, the number of ways that the event can occur. So in other words, what are we looking for out of the total possible outcomes? In other words, the part that I'm looking for out of the whole, all the possibilities there. Okay. Now, probabilities, when we look at the decimal form of this, probabilities are going to be between the numbers of 0 and 1 as the decimal. In other words, 0% to 100% in the form of a percent. Okay, so that's the probability of an event occurring. 0 means it's absolutely not going to occur. 1 or 100% means it absolutely is occurring or did occur. Okay, so that's what we want to keep in mind there. Now, when we are going to be calculating our probabilities, we're going to be using a probability table, because a probability table kind of helps us keep some of the information organized, and it also helps us when we're trying to look at conditional probabilities. It kind of gives us a little bit better hint on how to look at some of this. So let's take a look at how we're going to be using a probability table. So we're going to look at police officers. Now, we know police officers are either male or female. And in this particular case, we're going to be looking at those who were promoted in the last year and those who were not promoted in the last year. Okay, so here's the table that we've created here. Okay, male, female, promoted or not promoted. Here's the number of people in each of these. So male that were not promoted, 30 were not promoted, and there were 20 females not promoted. So if I total these, 50, I'm sorry, were promoted. So 50 people were promoted. Not promoted is 90 and 60, so male and female. So 150 were not promoted. Now, the thing about a probability table is we're going to have two totals. We're going to have a vertical total and a horizontal total. Both of these should total up to the grand total in the lower right-hand corner here. So both of these should add up to 200, and you can see both of these numbers do. Excuse me. So here's how we're going to be using a probability table. Okay, so which group of numbers sum up to 200? Well, all these numbers in the middle will add up to 200, which represents either these two numbers or these two numbers here. Okay, so once we get this organized in the form of a probability table, we're going to start asking some questions about this. Okay, so what is the probability an officer selected at random, remember random, think of names in a hat, I'm just pulling a name out of a hat, is female? Well, let's take a look here. How many people's names are in the hat? That's the grand total in this lower right-hand corner, 200. How many are female? Well, remember the part that's female is 80 out of that 200. So part out of the whole, so 80 out of 200. If they ask you to reduce it to the lowest fraction, you can see that that would be what, 2 out of 50, and that winds up to be 40%. So 40% of these officers would be female. Okay, let's look at a few others. Now, if I know 40% are females, the complement of that, in other words, the opposite, if I'm not female, that means I'm male, that would be 60%. Because remember, if I add up all my percentages of all the parts, they should total 100%. So that's what we refer to as the complement. If I can't remember to find the complement or the opposite that would add up to 100%, then we can use just the numbers. So what's the probability somebody is male? Okay, so male we knew is the complement of female, but we could also say 120 out of 200, which will still give me that 60%. Okay, so you can figure out probabilities sometimes in multiple ways, especially if one is the complement or the opposite of the other, because we know those percentages of whatever is there have to total 100%. Okay. Now let's take a look at when we start adding other meanings to this. What if we want to find the probability of selecting at random an officer who is a woman and was promoted? So now when we see the word and in the statement, and means both things have to be true, both of those criteria. So first of all, it's still telling me I'm picking somebody at random. That means I'm still picking names out of a hat. Only now, both of those things have to be true. So I come over here and it says promoted and then female. Okay, so that means 20 of the people out of this whole group were females that were promoted. Okay, so they're and promoted. So both things were true when we see the word and. So that's basically going to be 10%. Okay, can we find an officer who is a man who was promoted? Okay, here we go. A male would be 30 and promoted in the last year. Okay, so that's 30 out of the 200, or 15% of the men were promoted. Okay, so and were promoted. Okay, so when we use the word and when we're calculating probabilities, we need to take the value at the intersection of the criteria. In other words, both things have to be true. So that's why it's kind of easy to use a chart, because we can see where those intersections actually are. Okay. Now let's take a look at what if we use an or statement. Now, this one says, what is the probability of randomly selecting a police officer who is female or was promoted? Okay, so it could be one or the other. Well, let's start. We know we're picking at random. Okay, so if I'm picking at random, that means I'm using the grand total of 200 as my denominator, because it's the part out of the whole. The whole is 200. Okay, now I'm going to come over here. Female. Well, if I look here, female, there's 80 females. Okay, now, or was promoted. Now, when it says or promoted, they don't have to necessarily be female. It could be anyone that got promoted. So how many were promoted? If I look over here, 50 people were promoted. So I'm going to add the females. I'm going to add the 50 for the promoted. But take a look. We had a little bit of an issue. This number 20 here. This number 20 got used 2 times. It got used with the female. It got used with the promoted. So this overlaps. So when you see that there are overlaps here, you're going to have to subtract the overlap because you don't want to count it twice. So notice we had 80 plus 50, and then we're going to subtract that overlap of 20. Okay, so it's important to be really careful and reading these statements carefully here. So in this case, we have a 55% probability, because if I convert this to a percent, that I'm going to pick a name at random who is female or someone who was promoted in the last year. Okay, now let's take a look. What's the probability of randomly choosing a police officer who is male or not promoted? So when we're saying at random, that means I'm picking out of the grand total. So my denominator is going to be 200. That's my whole. Okay, so male. I'm going to look over here. I've got 120 male. It says not promoted. Well, didn't say if they're male or female, so I've got 150 of them, but I've got 90 that overlaps. It got counted twice in the male and then also got counted again in the not promoted. So see, I have to subtract away the overlap. Now, just because I have an or statement doesn't mean I'm always going to have an overlap. I might not have an overlap depending on what kind of question they're asking me here. So always take a look. If there is overlap and something did get counted twice, you have to subtract the overlap. So in this case, we can see that 90% of the officers were either male or not promoted. So I can pick a name, and that's the probability I'm going to get a name that's male or not promoted. Okay? Now, conditional probabilities. This is the tricky one. We really have to pay attention to the wording here. Okay, suppose we already know a certain condition. In other words, they're telling us just concentrate on a certain area. That's what they're saying, a certain portion of interest. When we're doing a conditional probability, we're not picking names at random, so we're not using the grand total. In this case, the denominator is going to change. The denominator is going to change according to the condition that we're looking at. So let's take a look at this, this example here. Notice it says, if a police officer is a man. All right, so it's not telling me to pick a name at random or just pick a name. It's already telling me if the police officer were a man. So it wants me to concentrate on just the male police officers. So since it's wanting me to concentrate on them, that means my denominator is going to change. So my denominator is going to be how many men? So that's going to be 120. Okay, that's the condition they want me to concentrate on. Okay, what is the probability he was promoted? Okay, so in this case, 30 out of the 120 men were promoted, which means 25%. Okay, so 30 out of the 120, 25% there. Okay, now here's another one. If a police officer is a woman, okay, so once again, they're setting up a condition. I'm only looking at the women here. So my denominator is going to be the total number of women, which is 80. What is the probability that she was promoted? So in that case, that would be what? 20 out of 80, which is also 25%. Okay, so this is kind of interesting. Even though we have different numbers of officers here, male and female, the promotion rate has actually been fair. 25% of the male, 25% of the female were promoted. Okay, so it's pretty much a fair thing that's going on in this particular police office here. Okay, so let's take a look at number 10. If a police officer was promoted in the last year, okay, now look at what they're wanting me to do. They're wanting me to focus on those who were promoted. So it's setting up a condition, okay? Then it's asking me a probability about that. So promoted, how many were promoted? Well, only 50 people were promoted, so 50 is going to be my denominator. Now, what is the probability the officer was a woman? All right, so that's going to be what? 20 out of that 50 or 40%. Okay. And then if a police officer was promoted in the last year, what's the probability the officer was a man? Well, since I'm still concentrating on those who were promoted, I can do it two different ways. I can figure out that that's the complement of the females that were promoted, which, if females were promoted were 40%, that means that 60%, in other words, the other number that would total to 100%, would be the males that were promoted. But if I can't remember the complement or that opposite situation, just literally plug in the numbers here. So that would be what? 30 out of 50, which winds up to be 60%. Okay, now look at number 12. It's worded a little differently. It's starting out with the probability statement. What is the probability the officer was a man? Okay, so they're asking me the probability first, and the condition is later in the sentence. So that's why you have to read that entire sentence, because you have to think, are they making me concentrate on a certain area of the probability table, or are they just asking me to pick a name at random? So they're saying if he were promoted in the last year. So I'm still concentrating on the promoted. Okay. So key words to look for are words like given, if, something like that. Now, sometimes those words won't be there, but if you can substitute the word given or if in the statement and it would make sense for the scenario, then you know you're dealing with a conditional probability. If they're just asking you to pick a name at random or out of everyone that's there, then you know that that's just a general probability and you're using the grand total, which would be in that lower right-hand corner there. Okay? So that's how we would calculate probability. So right now, what I'd like to take you through is how to create a probability table. And when we create probability tables, sometimes we wind up with false positives and false negatives. So let's take a look at a scenario here. All right. All right, so it's saying here, if you are tested for an allergy and you're told that the results are positive, does it mean you have the allergy? If you take a pregnancy test and get a positive result, does it necessarily mean you're pregnant? Well, we're going to go through a scenario here. In 1996, the AMA, they came up with a recommendation and they said they wanted to mandate HIV testing for all pregnant women. So we're going to look at the actual data and we're going to decide, was this a good decision that the AMA put out there? All right. Now, when we're talking about testing for allergies and different types of tests, this really is a good way to utilize a probability table here. Okay, so let's take a look. We're going to be looking at testing for HIV. Now, most people think if you test positive, that means you have it. But if you're told that you test positive, what's the actual chance that you have it? Sometimes we have false results. We have false positives and we have false negative results. So let's take a look. Let's set up and let's take a look at what is the accuracy of the test itself. Now we're going to suppose that the accuracy rate for the testing is 99% accurate. Okay, so what does that mean? That means 99% of the people who have the disease are going to test positive, right? So that's correct. That means if you don't have it, 99% of the people who don't have HIV will test negative. So always think, if the test is working correctly, what does that mean? All right. 99% of the time, positives are going to test people who have it. Negative means you don't have it. But, remember what's the complement of this? 1% of the time, the test is going to be inaccurate for some reason. Okay. 1% of the people with HIV are going to get a negative result. And that's going to be wrong. They actually have it, but for some reason the test didn't pick up on it. That's what we consider a false negative. And then 1% of the people who don't have HIV are going to test positive. That is also wrong, and that's called a false positive. Now, I actually have a test. If you have ever had those TB tests where they just do the little prick in your arm and they put that medication right underneath your skin, and then you have to wait a couple days to see if you have TB. I'm actually allergic, and my whole family is actually allergic to the antigens in um, that test there, the medication. So right away, we swell up immediately. So I test false positive for that. So when I was working in one of the school districts before, we always had to take the TB test every year. And the nurse already knew that I'm a false positive. And but I still had to take the test, but then they would just write it down as a false positive. So I was one of those people that the test for some reason didn't work correctly. And that's because I'm just allergic to it. All right, so let's take a look at how are we going to look at creating a probability table. Okay, so we're saying the test is accurate 99% of the time. So when we look in the form of a table, what does that mean? That means when we write the table, what are the two choices? Either the patient has it or they don't, right? And they're either going to test positive or negative. Now, if the test is correct and they have it, 99% of the time, they're going to test positive. If they don't have it, that means 99% of the time, they're going to test negative. Now, notice these are diagonal across from one another. The biggest mistake I see when students are calculating and creating their own probability table is they just follow the same order as the line above. That wouldn't make sense. If they don't have it, 99% of the time, they're not going to test positive. That means something's really wrong with the test there. 99% of the time, they're going to test negative. So be careful with that. That's the most missed mistake I see. Okay, so let's take a look. Now, in reality, only a small proportion of the population actually would have HIV. 0.5% actually. That's a very small percentage. So if only a half of a percent of people would actually have HIV in America, what proportion would not? So remember, both of these numbers would have to total to 100. That means 99.5% would not have the disease. Okay, so we really need to understand these percentages of people who would or would not have the disease. Because now what we're going to do is we're going to finish filling in a probability table based on 100,000 people selected at random. Okay, so when I'm doing this and I'm going to be selecting this at random, I'm going to be filling in the probability table here. Okay, so the questions that are right before this are actually what's going to go into the probability table. So the first thing you're going to do when you're creating your own probability table is, you're going to have this vertical and horizontal total here. The grand total is going to go in the lower right-hand corner. Okay, that's the very first thing you do. The next thing you're going to do is pay attention to how many people they're predicting would have or not have whatever you're talking about. Okay, so in this case, that means I'm going to have to fill in these numbers right here. Okay, so since they're saying only 0.5% would actually have it, and 99.5% would have it. What I want to do is calculate one of these. So what if we just did this and we took 0.5%? So 0.5% in the form of a decimal is 0.005. Okay, because if I move that decimal place, or in other words, take the percent and divide by 100, that's 0.005 times 100,000. And I come up with 500 people. Well, I know that these numbers have to total to 100,000, so I can just do a subtraction here to get this other number here. Okay, so this is the very first thing you're going to want to do when you're making your own probability table. Start with the grand total, and then you must do the totals first. The next thing you're going to do is you're going to work on the inside boxes, because the inside boxes now are related to how good the test is. This total out here was just telling me how many people are expected to, have it or not have it. Okay, so that's all I was figuring was a total. Here in the middle is the accuracy of the test. Now, if the test is 99% accurate, that means out of this 500 people, 99% will test positive here. So 99% of 500 is 495. And then if I add or I do a subtraction here, I know that 5 people would test negative. Because if I add these two together, I get 500. Okay, now remember, I'm not going to follow the exact same order here. Remember, they're diagonal from one another. So if I have 99,500 and I know the test is 99% accurate, I'm going to take 99% of 99,500, and that's this number here. That's going to test negative, because remember, we're saying the people who don't have it. Okay, and then I do a subtraction between these two and find this number here. Okay, now, when we look at this, then we're going to be totaling these columns here. Okay, and remember, the horizontal and vertical columns should total that 100,000. Okay, once I've gotten my probability table created, then I can start answering some probability questions. But you have to be careful how you're setting this up and pay attention to how they want that set up. Okay. And so what's the probability of having HIV if given a positive test result? Ooh, that's a condition. They're not asking me to take it at random. If you tested positive. So if I tested positive is right here. That means my denominator is going to be 1490. What's the probability of having it? That would be 495 out of that. So a 33% chance if you test positive, you're actually going to have the disease. What's the probability of not having it if given a positive test result? Okay, so that would be the complement of that, or 67%. Okay, what's the probability of having HIV if given a negative test result? So here's all my negatives. So my denominator is going to be 98,510. What's the probability of having HIV? That's only 5 people out of that. Look at the percent here. The percent would be what? 0.005%. That's a very, very small percentage out of the population of people who actually have the disease that would test negative. So really, is it right for the AMA to force people to pay for this test? Everyone who's pregnant pay for this test? So, we talked about it in my class, and some people say yes, they should test for it. And then some people say, no, it's really not fair because the percentage is so low. But what if you're just, it could be optional maybe. If you are somebody maybe in high risk, maybe that would be recommended for someone who would be high risk, because it's such a small percentage of people who would actually slip through the cracks. In other words, they would have a false negative result. Okay, and here would be my false positives because they don't have it, but for some reason they're testing positive. So just like me, they might be allergic to it. Okay, and it's automatically going to react with them and not necessarily react in the way the test is intended there. Okay, so that is how we would look at creating a probability table. All right, so that's that in a nutshell. So what I'd like to do now, we have about 20 minutes left. I'd like to go into the last section here, which is section 17, and this is called margin of error. So we've been gathering data and we've been finding the probabilities. Well, no probability is 100% accurate. There's always some room for some sort of error. Maybe somebody was collecting the data by hand and they wrote the result in the wrong column, or maybe there were two people next to one another and they were asked, who are you going to vote for in the next election? And the one person was afraid to say theirs out loud, so they just agreed with the other person. So, there's always room for error, just, different types of error. And that's what we're going to be looking at, is what we consider margin of error. Now, in order to understand margin of error, we have to make sure that when we are taking samples that they are not biased. So we definitely want to just take random pieces of information or ask random people. We don't want to go into a primarily Democratic city and ask who they're going to vote for the next presidential election, Democrat or Republican, because we know what the results are probably going to lean towards. So we would have to go through numerous cities or numerous areas so that it wouldn't be biased. Now, population, when we're taking a poll or we're gathering data, refers to all the people or all the objects that we are collecting information on. Okay, so the population is the big group. The sample is a subset of the population. The sample is a size. Okay, so think about it. The word sample starts with the letter S. Size starts with the letter S. So in other words, when I'm asked about the sample, I'm going to say how many people were asked or how many things were collected of data. So sample is going to be a size. Population is going to be a word telling me, who did you ask or what data was collected there. Okay, and then here a school newspaper is gathering opinions about the average time spent on homework. They set up a table in the cafeteria and ask everyone who walks by. That's fair because they're asking everyone. Okay, what if you're rating the pros and cons of creating additional playgrounds in the city and you just visit the playground nearest to you? Well, that's going to be biased because you didn't get a sample of the whole city. You just got one area. Okay, so that's what they're talking about, is something biased or not. Okay, let's take a look. So let's go through a scenario and try to understand how would we look at a poll here. All right, so we're going to look at some data here. Okay, so this data here, this chart is telling us people who have cell phones and they use the internet on it. So cell internet use. Okay, notice it says nearly 2/3 or 63% of cell phone owners now use their phone to go online, according to this Pew Research Center. So this is a real thing. Pew Research Center is a real, you know, organization, and they actually randomly ask people questions. And what was really funny is about I want to say it's probably been 3 years now. When I was teaching this, one of my students was laughing. She goes, "No, this is real. We actually got this in the mail." And they pay them like $10 if they were to answer this questionnaire. They were gathering some data. So I thought that was kind of funny. I didn't know that's how they did it. It was like through the mail. Okay, so because 91% of Americans now own a cell phone, if I take 63% of that 91, that means 57% of all American adults are cell phone users. Okay, so that's what that's basically saying in the paragraph there. Let's look at some more data here. Now, underneath this, it's actually giving me a little bit more information also. It's telling me the sample size. Okay, the sample size is 2,076 people. What sample is taken? Okay, so it's saying that this was for cell phone owners 18 and older. And when's the dates that this information was taken? Between April 17th and May 19th of 2013. Now notice they show a plus or minus of 2.4 percentage points. This is the margin of error. Okay, so polls will always show a potential margin of error. That means that the data can be a little bit more or a little bit less than what they actually are telling you to fall within that margin of error. So let's take a look at this. Okay, all right, so because of the possible variations in responses from sample to sample, okay, a margin of error is always going to be associated, and we're always going to refer to a margin of error as being 95% accurate. All right, so whenever we attach and we say what the margin of error is, the margin of error, just by sake of what it is 95% accurate, because we know a margin of error, once again, can't be 100% accurate. Okay, so this is going to give an approximation of how far off a reported percentage might be. Okay, so it allows for possible mistakes within the data. We can never say anything is for certain. We always have to include that margin of error. Okay, so when I include that margin of error, like we had that 2.4% that was listed there, basically what we're going to do is when we want to apply the margin of error, we're either going to be adding or subtracting that from the sample percentage that they're talking about. Okay, when we add and subtract that number, we're actually coming up with what they refer to as the confidence interval. Okay, so when they said, 63% of cell phone users use their cell phones for internet usage, well, if they're saying 63% is the number and we apply the margin of error, add and subtract that 2.4%, we're basically saying that between 60.6 and 65.4% are the actual values. So how would I word that? So we have to state, okay, and I'll be looking for these words in your exam. Hint, hint, okay? Since we applied the margin of error and we know the margin of error is 95% accurate, I have to state that in my statement explaining what the confidence interval is. So look at what they said. We are 95% confident that the true proportion of all cell owners that are internet users is between 60.6 and 65.4. Somehow, when you are giving me the confidence interval, once you've applied that margin of error and you've given me the number below and above, you have to state somehow that you are 95% confident, or within 95% accuracy, the numbers fall between this and that. You must state those words, 95% confident somehow. Okay, because that is telling me that you applied the margin of error. That's what that means, that you've applied the margin of error and it falls between those two numbers. Okay, so I want to go through a sample problem. I want to find the problem here that you might see on the exam or quiz. So let's take a look at this example problem. This is pretty much a sample that you might see. Okay, so this is from a Gallup poll. So that's another organization that collects information. And we really do look up things on Pew Research and Gallup. I actually get regular emails from Gallup giving me data that I sometimes use in quizzes. Okay, as Independence Day approaches, most in the United States say that they are proud to be American, including a slight majority, 54%, who are extremely proud. Now, the percentage say that they are extremely proud is slightly lower than in recent years and down from peaks at around 70% between 2002 and 2004. And that was right after 9/11 there. Okay, so it says results for this Gallup poll are based on a telephone interview. Here it was conducted between Junes 2 and 2nd of 2015. A random sample of 1,527 adults who were 18 years and older who were living in the United States and District of Columbia. Okay, now it's giving me all the information I need to know within this paragraph. So now I want to answer the questions that I would see on an exam about margin of error. Okay, so what is the population? Remember, the population is the big group. In other words, who or what was polled. Okay, so that's going to be a word. So American adults, or you can say adults 18 and older, something to that effect. How big is the sample, or what is the sample? Well, I know sample is a size. It must be a number. So that's the 1527. I can't tell you how many people mix these two up. Many, many students mix these two up. They miss the sample and the population is different. Remember, sample is a size, which means it's a number. Okay. Now, if the margin of error is reported to be 2.6%, can we calculate the confidence interval for Americans who are extremely proud to be an American? Well, if I come back up here, 54% say they're extremely proud. So now if I apply the margin of error, I'm going to add and subtract that 2.6%. So I'm going to get the two numbers here, 51.4 to 56.6. This is my confidence interval because I've applied the margin of error. Okay, so if I were to create a statement based on this, I would have to say something to the effect that I am 95% confident that between 51.4 to 56.6% of Americans are extremely proud to be an American. Okay, so I'd have to say something to that effect. Okay, now look at D. Can it be concluded that most Americans are extremely proud using this poll? Well, since both of these numbers, once I've applied the margin of error, is bigger than 50%, which is half, we could say yes, because both of these numbers are greater than 50%. Okay, so right here, this problem right here is a sample problem that you might see on the coming up quiz for section 17 and a possible type of setup for an exam question. Okay, so that's why I wanted to make sure I went through this problem in enough detail here. Okay, so that's what that means with polls and margin of error, because we can never be 100% sure that's what we've got there. Okay. Alrighty, so that's the basics of section 17, and there's some additional sample questions that you can look through if you want to watch Becky's videos there also. Right, so looks like I've got about, what, 4 or 5 minutes left. This is all I have for you right now. Those of you who joined me late, make sure you've got your test, your final exam scheduled, because that's coming up very quickly. If you are going to be using ProctorU, I need to know today if you're going to be using ProctorU. I need to make sure that they have it and you're going to be able to schedule a time with them, because they're very busy at end of the semester time. Because don't forget, we're not the only school that uses them. All right, so if you have no other questions, and I'll stick around if you do, this is all I have for you today. And next week will be a review, and watch in the announcements. I should have a list of topics that you should cover and start to review for the final. Okay, so I'll talk with you next week. Okay, did you have any other questions? It looks like you're the only one out there.